Okay, yes, we are live, guys. Okay, so you can see we are live. Okay, so yes, today we'll be continuing with the number system part 2, right? Without wasting much of the time, let's go into our promotions. So you guys know the Mega Gate and ESE Combat is going to be live on the 11th of June, right? 11th of June at 11 a.m. it will be there. So you guys will be getting, right, anyone who gets below 100 ranks, he'll be getting free Unacademy subscriptions, and 500 lucky winners also get a chance to win amazing goodies. To enroll into this, please use my referral code SAYT. If you use my referral code SAYT, you guys can easily enroll into this combat. Okay, yes, these are the prices of the combat. You guys can see, yes. So the price hike has been postponed, so you guys won't be seeing the price hike soon. So please do buy your subscription as soon as possible. Right, these are the new batches which has been uploaded for you. So you guys can see the plus subscription, everything which is in blue, right? These are the eminent features of the plus subscription. And if you go for the iconic one, along with the blue things, you guys will be getting all the orange, yellow ones, right? All this will be also included in your iconic subscription. So you guys can see the GATE and ESE subscription. These are the prices. So if you people go for the 12-month plan, you guys will be getting 3 months extra. If you go for the 24-month plan, you guys will be getting 6 months extra, right? Use my code SAYT where you guys will be getting 10% off and buy the subscription, right? Buy the subscription. And also for programmers, the Unacademy Maestro Scholarship is coming. So this is also going to be live on the 11th of July at 7 p.m. right? So this is for all those people who want to learn placement aptitude. Okay, yes. So and you guys can see, so these practice tests are already over. So there are 2 more practice tests at the same time. So please do get into the practice test and go for the main test on 11th of July at 7 p.m. Okay, 11th of July at 7 p.m. I'm really sorry. So yes, so let's begin with this. So today I'll be taking the number system part 2. Right, once the number system is done, so in the next 2 classes, probability, and in the next 2 classes I'll be taking probability as well as permutations and combinations. Then I'll be going with all the reasoning things, right? So I'll be teaching you guys the blood relations, the concepts of blood relations, concepts of seating arrangements, concepts of directions and distances, concepts of clocks and calendars. All these concepts will be dealt to you people. Okay, yes. So now let us start with our class, right? And this is going to be number system part 2, right? So in today's class, I will be taking some reminder theorems for you people and also the unit digit methods, right? The unit digit methods we did it. Okay, yes. So one question will come like this, right? So what are the total number of integers? What are the total number of integers between 100 and 400, right? Which are between 100 and 400, which are divisible, right? Which are divisible by both 9 and 6, right? So you guys will be getting this question, right? So which are the integers which are divisible by both 9 and 6? 9 and 6. So can someone tell me the right answer there? Can someone tell me the right answer there, right? Which are divisible by both 9 and 6, 100, between 100 and 400. How many integers will be there, right? How many integers will be there between 100 and 400 which are divisible by both 9 and 6, right? Yes. So whenever they give you guys such questions, what you have to go? You have to go to our previous friend who's given the name LCM, right? Find out the LCM of 9 and 6. What is the LCM of 9 and 6? 3 2s are 3 3s are 3 2s are 3 3s are, right? 6 3s are 18. Right? 18 will be my LCM, that is both of them have to be divided by 18, right? So yes, let me take 100 divided by 18. So I know 18 5s is 90, right? 18 5s is 90, so I'm getting 5 here. So yes, the same thing again, 400 divided by 18. So 18 5s is 90, right? So I can tell 5 4s are, right? So if I go with that also, so 94s are kitna hai? 9 4s are 36, 360. So I'm still left with 4, right? So how much is this going to be? So yes, 18 into 9 4s are, right? So 18 10s are 180, 18 11s are, right? 18 10s are, 18 15s are, 18 20s are, I'm getting 360, right? I'm still left with 4, right? So 18 2s are 36. So how much I'm getting? 22. Yes or no, people, right? 18 into 22. 8 2s are 16, right? 8 2s are 16, 1 to the carry, 8 2s are 16, 1 to the carry, right? Yes. So this is 176 here. Then again 1 2s are 2, 1 2s are 2, right? So this is going to be 6, 7 plus 2 9, 396. Yes or no? 396. So this is between 400 only, right? Yes. So yes, now we have got this question. Now we have got this question. So what will be this? Adding both? No. If you see, I've written it as between 100 to 400. I've written it as between 100 to 400. Now you guys carefully observe here, between 100 to 400, 90 does not come inside 100. Yes or no? After 100 I should go. That means I should go for the next digit, right? From 101 to 399. Yes or no? So this is going to be 5 plus 1, right? So whenever you guys get such questions, what you guys will do, you'll subtract both the quotients and add plus 1, right? 22 minus 5 plus 1, right? So this is going to be 22 minus 5, 17, 17 plus 1, 18. So 18 will be the total number of digits between 100 and 400, which are divisible by both 9 and 6, right? So like 6, lots of questions will come between 100 and between 1000 and 2000, between 3000 and 4000, divisible by both 10 and 20. What you guys have to do? You guys have to go for this. You guys have to go for the LCM method. So the next concept in the number system is you guys will be getting a question, right? Okay, so the question will be as follows. A two-digit number is 4 times the sum of its digits. Okay, a two-digit number is 4 times the sum of its digits. If 18 is added, if 18 is added to the number, if 18 is added to the number, right, then it becomes 7 times its digits, right? Then it becomes 7 times, right? Then it becomes 7 times its digits, right? Then it becomes 7 times its digits, right? These are the questions. They are asked a lot in most of the PSUs, right? What is this two-digit number, right? What is this two-digit number, right? What is this two-digit number? Okay, yes. Okay, what is this two-digit number? You guys have to find out. Right, first of all, a two-digit number is 4 times the sum of its digits. Yes or no? A two-digit number, in the first class only, in the previous class of number system, I told you guys, what is it? It is nothing but 10x plus y. Yes or no? So that two-digit number is 4 times the sum of its digits. The digits will be x and y, right? So this 10x plus y is going to be 4 times the sum of its digits. That is 4 into x plus y. What is the next one I have done? If 18 is added to the number, right? If 18 is added to the two-digit number, right? So this will be 10x plus y plus 18. It will become how much? 7 times its digits, right? 7 times the sum of its digits, okay? 7 times the sum of its digits. So here I can easily cancel, right, people? That here I can easily cancel. 10x plus y, 10x plus y I can cancel. 7 minus 4. So I can take it as 18 is equal to 3 times x plus y. So this will be equal to what? So x plus y is going to be what? X plus y is going to be 6, right? X plus y is going to be 6, right? X plus y is going to be 6. Now take any one of these. Take any one of these. So I'll be taking the former equation and solve it. Okay. So I'm solving this down. Okay. Just a minute. Okay. So this is going to be what, Baba? Right. So this is 10x plus y is equal to 4x plus 4y, right? 10x plus y is equal to 4x plus 4y. So move the 4x here, move the y here. So this is going to be 6x is equal to 3y, right? So can I write x bar y here? So I'm getting the value of 3 bar 6. 3 bar 6 I can also write it as 1 bar 2, right? 3 bar 6 I can also write it as 1 bar 2, right? So here what am I getting? What is this? This is going to be x. This is going to be y, right? I know x plus y is equal to 6. So if I substitute the ratios here, if I substitute the ratio, so this is going to be 3r is equal to 6. So what is going to be the value of 1r? Value of 1r is 2, right? So yes, I got my number directly here. So the value of x is going to be 2 and the value of y is going to be 4. So what was the two-digit number? The number was 24. What was the 2-digit number? The number was 24, right? So here, instead of doing all this, right? So when they tell 4x plus y, 7x plus y, directly, right? Don't you guys think directly I can take this 18 and I can subtract these both directly, as I've told you the concept directly. Take the 18, subtract these both, you guys will get the value of x plus y. Then take any one of them, formulate it, you guys will get the answer, right? One of the most pertinent questions asked in most of the PSUs, right? You guys can see it here, okay? Now, moving on to the next part. Yes, okay, we are left with, so anyways, I will be finishing off number system in today's class, right? I'll be finishing off number system in today's class, right? You guys know the divisor theorem also. So I'll be just writing down the divisor theorem for you people, right? I'll be just writing down the divisor theorem for you people. Okay, yes. So divisor theorem, everyone might have known this. You guys will know what is a divisor theorem, right? You guys will know what is a divisor theorem. What is a divisor theorem? In divisor theorem, you guys have something called as the dividend. Dividend is always equal to quotient into divisor minus remainder. Quotient into divisor minus remainder. Yes or no? So if I take a number 24 and am I dividing this 24 by 4, 4 6 are 24, so 24 as I 0, right? So here my dividend is 24, right? My dividend is 24, my quotient is going to be 6, my divisor is 4 minus 0. Yes or no, right? This is how, this is what is the divisor theorem. This is what is the divisor theorem. So moving forward, right? So I don't think so you guys need to learn the prime factors and all, but still I will be telling you guys, right, how to go with the prime factors, how to go with the factorization theory. So the factorization theory, and next you guys will be having the remainder theorem, factorization theory and the remainder theorem. So factorization theory, let us go with the big number, right? Let us go with the big number here. Okay, so let us take up a number, just a minute. Okay, let us take up a number. Let's take up a number 36. Okay, yes, 36. If I am doing the factorizations here, right, 36 I can easily write it as 12 3s are 12 into 3. And what is actually 12? 12 is nothing but 4 into 3. Yes or no? 4 into 3 into 3. So this 4 is nothing but 2 square, right? So this is 2 square into 3 square. Can I write it? Right, 2 square into 3 square, because 9 4s is 36. Yes, 9 4s is 36. Okay, now let us find out the total number of factors, right? So if it is 2 square, I should go with all dark pens, right? Yes, so 2 square means 2 power 0, 2 power 1, 2 power 2 will be there. Here 3 power 0, 3 power 1, 3 power 2 will be there, right? Yes, so what are the total number of factors 36 will be having? What are the total number of factors 36 will be having? 3 on this side, 3 on this side. So 36 will be having a total of 9 factors. 36 will be having a total of 9 factors. What are the odd factors 36 is having? What are the odd factors 36 is having? You guys can clearly see odd factors matlab 2 power 1 is 2, 2 power 2 is 4. So this cannot be odd factor. So this is one of the factors, and 3 power anything is going to be odd itself. So 1 into 3, right? There will be a total of 3 factors. Next, moving on to the number of even factors, right? Total minus odd. Total minus odd. So this is going to be 9. Okay. Total minus odd, right? 6 factors, right? So this is going to be the number of even factors. And finally, you have the prime factors. What are prime factors? The addition of powers of the last, right? The additions of powers of the last factor. That is 2 plus 2, right? You guys will be getting 4 factors, right? Yes. Okay, then how many perfect squares are there, right? How many perfect squares are there here? Okay, let us just see it. How many perfect squares are there, right? You guys can see 2 power 0 is also a perfect square, because 1. 2 power 0 is what? 2 power 0 is 1. So what am I getting? 2 power 0 is 1. So it will be 1 itself. 1 is nothing but a perfect square. Then I am having 2 square also. Yes, very good. Then 3 power 0 is there. Then I am having 3 square also, right? Yes, there are 4 factors which are perfect squares. There are 4 factors which are perfect squares. 2 2s are, right? How many perfect cubes am I having? How many perfect cubes am I having, right? So yes, 1 is a perfect square as well as a perfect cube, right? So 2 power 0 and 3 power 0, right? Yes, how many perfect squares am I having, people? So you guys will be telling 2, no, right? It is going to be only 1, okay, 1 factor, because this is also just like your total number of factors. So with the 2 I am having 2 factors, with 3 I am having 2 factors, so 2 2s are 4. With the 2 I am having 1 factor, with 3 I am having 1 factor, 3 1s are 3. Now, okay, so now let us just for a minute write down the factors of 36, right? Yes, so what are the factors of 36? 1, 2, 3, 4. Yes or no? All can be there, right? Yes. So if I take with this 4, 4 watts are 4 nines are 36, right? 4 nines are 36. 3 watts are 36. 3 12s are 36. Right? Yes or no? 3 12s are 36. 2 watts are 36. 2 18s are 36. Right? 2 18s are 36. Then you are left with 36 itself, right? 1, 2, 3, 4, 5, 6, 7, 8. So I might be missing one more factor here. Just a minute. Yes, 6 is also there. No, 6 6 are 36, right? Yes, 6 6 are 36 and 36. Yes, you guys can see the total number of factors for this is 9. The total number of factors you guys are getting here is 9. So here you guys can also find out, right? Here you guys can also find out how many factors are divisible by 3, how many factors are divisible by 6. All these things can be found out by you people. All these things can be found out by you people. Now moving ahead with the remainder theorem. Now moving ahead with the remainder theorem. Okay, only 3 more theorems left. Okay, remainder theorem, right? In the remainder theorem, you guys have to progress until you get -1 to the power n or +1 to the power n. Right? You guys have to progress until you get -1 to the power n or +1 to the power n. So how are you getting -1? So if I get a number, if I take a number, right, 7 divided by 9. What is the remainder here, guys? You guys will be telling remainder is 7. Yes, remainder is 7. Yes, you guys are true. But there is a negative remainder also I'll be getting here. Right? There is a negative remainder also I'll be getting here. Yes or no? Right? What is that negative remainder? 7 is 7 more than what? 9 into 0. That is 7. 7 more than this. But if I take 9 into 1, this is going to be 9, right? So I can also write -2 is one more remainder of it. Right? I can also write -2 is one more remainder of it. So if I take 15 divided by 13, right? So what is the remainder? What is the remainder I'll be getting? Right? 15 divided by 13. What is the remainder I'll be getting? 13 ones are, right? So it will be 13 plus 2 is there. Yes. So I'm telling. So if I take 13 ones are here, is going to 13. The next consecutive number is 13 twos are 26. So this one is actually +2 and -11, right? So this is what is your remainder theorem, right? So if I have a question 11 power 143 divided by 9, and they ask you to find out the remainder of this question, you guys can use the theorem over here, right? So 11 power 143, I can write it as what? 11 power 143. First of all, I will find the remainder of 9 to 11, right? What is the remainder I'm getting? +2, right? 2 power 143 divided by 9. Yes, any issues? No. 2 power 143 is there. So you guys know which is the most closest remainder to 9, which will give me -1 or +1. Which is the most closest remainder of 9, which will give me -1 or +1. That is 8. And 8 is what? 8 is 2 cube. So if I take 2 cube here, 143 is not divided by 3, right? But 141 is, right? So 3 into 47. 3 into 47 will give me 141. 3 into 47 will give me 141. And the remaining digits, right? So 143 was there, 141 plus 2, right? 2 cube 47 into 2 square divided by 9. So 2 cube is going to be 8. 8 power 47 into 4 bar 9. So what is 8 power 47, people? 9 and 8, right? -1 will come here. -1 to the power 47 into 4 bar 9. So you guys know -1 to the power odd. Yes or no? Minus to the power odd. Minus to the power odd is going to be what? It is going to be -1 itself, right? So what will be my remainder? -1 into 4. My remainder is going to be -4 for this question. Yes, my remainder is going to be minus 4 for this question. Similarly, there is one more theorem. Okay, first I will finish off the theorem, and if I am left with the time, I'll be going forward with the next one, right? If I'm left with time, I'll be going forward with some questions. Okay, yes. So the next theorem I have is called as the Fermat theorem. The next theorem I have is called as the Fermat theorem. So if you guys go with the Fermat theorem is a rule for prime numbers. Fermat theorem is a rule for prime numbers. Only if prime numbers are there, this theorem will work. Right? Only if prime numbers are there, this theorem will work. So if I am having something in the form of n into p minus 1 by p, then the remainder of this theorem is always going to be 5. Yes, only given that p is a prime number. Only given that p is a prime number. So if I take a question 7 power 82 bar 11. 11 is a prime number? Yes, for sure it is. 11 is a prime number? Yes, for sure it is. So this can be written as what? 7 power 80 into 7 power 2 divided by 11. 7 power 80, right? 11 is there. P minus 1 means I should get 10. P minus 1 means I should get 10. So can I write it like this? 7 power 8 into 10 into 7 square by 11. So what does Fermat tell? He tells cancel the term off, right? Because minus 1 aa gaya hai, right? So this is going to be what? So this is going to be 49 bar 11. My remainder is 5 itself. Wow, right? My remainder is going to be 5 itself, right? Yes. So let us take one more example here, right? Let us take one more example, right? I am having a number. So let us consider this as 9 power. 9 is written properly, yes. So let us consider this as 9 power 87 divided by 13. What is going to be the remainder? 9 power 87 divided by 13. See, if you get a prime number, you can close your eyes and write the option 5. If you get a prime number, you guys can close your option, write the 5. But still we will solve this. 9 power 87. So I can write this as 9 power 84 into 9 power 3. Okay, 9 cube divided by 13. So 9 power 84 is what, Baba? Right? 7, right? 9 power 7 into 12, right? 12 6 are 12 5 are 60, so 6 are 12 5 are 60, 12 6 are 72, 12 7 are 84, right? Yes. So this is 9 cube again here, and this is going to be 13, right? So Fermat tells, what does Fermat tell? Cancel it off, right? Cancel it off because minus 1 is coming here. 13 minus 1, 12, right? So what am I getting now here, people? So 9 cube is 729. 729 by 13, right? Yes, the remainder is 5 itself. The remainder is 5 itself, because here also I can easily do this. So 13 ones are, right? 13 fives are 65. Yes, 13 fives are 65 because 50. 13 fives are 65. 13 sixes are 78, right? So I have to go with 13 fives are 65 itself, right? I'm left with 79. Again 13 sixes are, right? 36 are 78. Kitna bacha mujhe? Right? 36 are 78. Yes, I've got 13 this only, right? If I just go with this also, 13 into 56. I'm not getting a remainder 5, right? I'm not getting a remainder 5 here. 9 cube, did I write it wrong? I'm not getting a remainder 5 here. So this is wrong again, right? Okay, 729 is correct. 9 cube. So 84, right? Plus 3. Where am I going wrong? 84 plus 3 is 87. 7 12s are 84. Huh? The remainder, anyways, I'm getting 1 here. I'm getting 1 as the remainder. But that shouldn't be the case, because according to the theorem, the remainder should be 5 itself, right? Okay, I might be wrong with this remainder theorem concept, right? So the remainder can be 5 or 1. Okay, I think it is 5 or 1. I think it is 5 or 1. It is not 5. I think the remainder theorem is 5 or 1, not just 5. It can be, okay, because here I am getting the remainder as 1, right? You guys can see it clearly here, right? The remainder is going to be 1. So I cannot tell this is going to be remainder is 5 or 1. Okay, I think it is 5 or 1. It can be just 5. Sometimes it can be 5. Sometimes it can be something else also, right? So 11 fours are 44, right? There the remainder was 5. Okay, yes. So Yes, the remainder is 5 or 1. Sorry there. Okay, I just got confused with the concept. So the remainder is going to be 5 or 1. It is not just 5. Okay, so this was the Fermat's theorem. Next, you guys have something called as the Wilson's theorem. Next, you guys have something called as the Wilson's theorem. So I'll take one problem because we do not have time left. Wilson's theorem and Toscan's theorem of cyclicity, it will finish off this, right? What is Wilson's theorem? Wilson's theorem is p minus 1 factorial divided by p minus 1 factorial divided by p, and the remainder is always going to be minus 1, right? p minus 1 factorial by p, remainder is always going to be minus 1. ठीक है, तो एक उदाहरण ले लेते हैं, 6 factorial by 7. yes or no, right? P minus 1 नहीं है, right? 7 minus 1 is 6. So 6 factorial is what, Baba? 6 into 5 into 4 into 3 into 2 into 1 divided by 7. So what am I getting? I am getting 720 bar 7. Yes or no? I'm getting 720 bar 7. So 7 tens are 700, right? 14. Yes or no, right? 700s are 700, 702s are, right? So the remainder will be what, Baba? The remainder will be either 6 or the next one is 721. The remainder will be minus 1, right? The remainder is going to be minus 1. The remainder is going to be minus 1. Okay, it's always right. So here also they have given it as p, right? So p has to be a prime number, right? P has to be a prime number. Okay, let us take one more example here. Okay, let us find out 10 factorial. I can't give the right answer here. Okay, so 5 factorial I can do, but 4 is not a prime number, right? So I can take 4 factorial by 3. Okay, just for the proof reference here, I can take 4 factorial by 3, right? Yes, 4 factorial by 5. 4 factorial by 5 can be took here. Okay, so 4 factorial is going to be what, people? It's going to be 4 into 3 into 2 into 1 bar 5. 4 3s are 24, right? 4 3s are 24, 24 bar 5, right? So here also you guys can see the remainder is going to be 4 or the remainder is going to be minus 1, right? Whenever you guys get a question of this area, whenever you guys get a question in the basis of the Wilson's theorem, you guys can tell this, right? In the basis of the Wilson's theorem, you guys can tell the remainder is always going to be minus 1, right? The remainder is always going to be minus 1. Now we are only left with the Toscan's method, okay? So what is the Toscan's method? You guys might be having a doubt here, right? What is the Toscan's method? So Toscan's method is also for prime numbers itself, right? Toscan's method is also for your prime numbers. So what do we do in Toscan's method basically? What do we do in Toscan's method is, in Toscan's method, we find out the cyclicity of a prime number. कैसे cyclicity of a prime number करते हैं? Okay, just 5 minutes I'll take extra. Just 5 minutes I'll be taking extra. So what is first of all a cyclicity? So I don't think so I have enough space also here, right? I have to finish it off here. What is a Toscan's method? What is the Toscan's method? Right here we find cyclicity. So what is cyclicity first of all, right? What is cyclicity? So if I take 4 power 1, it is always going to be 4, right? So cube wala karo, right? 4 power 3, right? 4. 4 power 7, it is also going to be 4, right? This is what is cyclicity. If I take 6 power 1, 6. 6 square, 36. 6 square, 36, yes or no? 6 is cube, 216, right? The cyclicity, the end unit digit is going to be 6 itself. If I go for the another number, 9. 9 power 1 is 9. 9 power 2, right? 9 power 3, 729. 9 power 5, 099, right? Yes, so you're getting 9. So this is what I call it as cyclicity. So if a small number is given for you people, such as 2 power 112 bar 7, always remember your denominator has to be a prime number. Your denominator has to be a prime number in your Toscan's method. अगर prime number नहीं है तो prime number कर दो. Prime number नहीं है तो prime number कर दो. 2 power 112 by 7. What is going to be this, right? 2 power 112 by 7. So how shall I find out the cyclicity here? How shall I find out the cyclicity? First of all, you guys have to go, right? You have to understand what is going to be the cyclicity of 2. What is going to be the cyclicity of 2? ठीक है? तो 2 को इधर 112 है, so cyclicity of 2 क्या होगा बाबा, right? So if I take 2 power 1 bar 7, my remainder is going to be 2. 2 power 2 bar 7, that is 4 by 7, my remainder is 3, right? And 2 power 3 bar 7, 8 bar 7, my remainder is going to be 1, right? My remainder is going to be 1. So if I take the same thing 2 power 4 bar 7, right? If I take the same thing 2 power 4 bar 7, don't you think the cyclicity is repeating here? 16 bar 7, remainder is 2. 2 power 5 bar 7, 32 bar 7, remainder is, right, 2 power 5, 32 bar 7, right? So 32 bar 7, my remainder is 4. So I'm not getting a cyclicity here, so I have to still go further. Right? Then 2 power 6 bar 7, right? 64 bar 7, right? 64 bar 7, 7 9 is 63, 1. So I'm not getting a proper cyclicity here, right? I'm not getting a proper cyclicity here. So मैं क्या करूँगा, इस जो 112 है, right? This 112 is there, so this I will be dividing by 3. This 112 is there, this I'll divide by 3 because this is 2 square, right? So this 112, I'm dividing this 112 by 3. When I divide this 112 by 3, how much I'm getting, right? When I divide the 112 by 3, when I divide the 112 by 3, how much I'm getting, people? 2 power 3 से तो कटेगा ना ये, 3 से तो नहीं कटेगा ये, 2 power 112 by 3, no, okay? ये तो 2 से नहीं कट रहा है, ये 3 से नहीं कट रहा है, 1 मिनट को. Okay, yes, always in cyclicity what happens is, always, okay, there is also one more method here, right? I'll be applying that method here. In cyclicity what happens always is, right, you guys will be getting a question like this: a power 112 bar b, right? A power 112 bar b, right? तो इसका जो रिमाइंडर होता है, right, the remainder of a you should write it here, right? The remainder of a you should write it here, okay? तो ये करूंगा तो 2 power 5 आएगा ना, तो 2 power 5 का क्या था, 4 था, right? 2 power ये करना पड़ेगा, so this is going to be 2 power 1 bar 7, right, which is nothing but 2 bar 7, and the remainder is 2, right? The remainder is going to be 2. Okay, yes, actually we are not having a time here, right? We are not having time here, it's already 32 minutes, right? So this torsion method I will describe it again in the next class. Okay, you guys don't have to worry because I do not have space. Also, you can see I'm already at the end of this, and this Microsoft Word has a very slow eraser. Okay, I'm already at the end of this, right? So tomorrow I'll be taking it again. Cyclicity is nothing but a power n by b. Cyclicity जो है, ये cyclicity जो भी है a power n bar b होता है. a power n bar b हमारा cyclicity होता है. So the torsion method I'll be taking it again in tomorrow's class. I'll be taking in the torsion method in tomorrow's class. So this will take around 5 minutes, and then we will start with our probability. Right? Then we will start with our probability. Okay? Yes. So thank you guys. I will see you guys in the next class. Have a good day ahead. Take care. Bye bye. Please do stay safe, stay indoors, and get vaccinated. Let's crack it.